Okay, hi, so this 4.7 applications of motion charge, particle MB and E. So basically, the setup that I give to you is a mass spectrometer. So its mass spectrometer function is to detect the unknown charge. So we need to determine the unknown charge. Okay, so we have one unknown charge. I'm going to use mass spectrometer to find the mass of the charge. Then kita computekan dekat you punya periodic table tu and find which one is which lah. Alright, so there are two parts here. So the first part is velocity selector. The other part is dia punya mass spectrometer sendiri. Okay, so in velocity selector, kita ada positive charge. We don't know what the charge it is. Okay, so dalam charge ni kita akan buat positive, then there ada velocity. So the velocity is to the right, okay, ke kanan. So kita ada plate positive, plate and negative plates. So because kita ada plate positive and negative, there are differences in the electric potential. So there ada electric field in between these two plates. Okay, so what is the directions of electric field in between two plates adalah ke pandai. So dia adalah ke bawah. Sebab positif bergerak ke negatif, kan? Alright. So in the same time, okay, at the same moment, this charge passes through electric field and also there is a presence of magnetic field. This is what I did as a cross ni lah, magnetic field. Okay, so we learned already in chapter 1. When we have positive charge, there's electric field. So there will be the charge going to experience apa dia? The charge going to experience electric force. Okay, so electric force akan tertarik. This is positive, going to attracted to negative plates. So going to experience electric force downwards. So saya tukar color bright sikit. So dia akan experience, this is electric force. Okay, and because dia punya charge ni masuk dalam magnetic field, dia akan experience magnetic force. Okay, so kita guna right hand palm rule to determine the magnetic force. Okay, so kita guna yang betul-betul dekat Google tu lah. Okay, kat finger, what will be the directions of magnetic field? Okay, your fingers, your thumb will be the directions of the velocity. Then your punya palm will be directions of force. Okay, so awak masukkan tangan awak ke atas kertas, ikut directions of magnetic field. Then thumb awak will be directed to the right, follow directions of velocity. Then you punya palm will be direction of force lah. So palm awak menghala ke mana? Ke atas. Okay, so what do we do here? So basically, kita akan tetapkan value of electric field dan juga magnetic field. Okay, supaya FB ni kita akan make sure dia sama dengan FE. So what happen when they are equal? They're going to cancel out each other. If they cancel out each other, means that submission of forces in X component of the charge ni akan sama dengan kosong. Sebab apa? FB sama dengan FE. Okay, FB sama dengan FE. So FB we learn already is QVB sin theta. FE equal to QE. Right? So how about the theta here? Theta is the angle between V and B. Okay, so V ke kanan, B awak ke dalam. So it will be 90 degree. Theta awak sama dengan 90 degree. Saya tulis kat sini. Okay, so Q cancel out. Dan kita dapat velocity awak adalah E over B. Okay. Okay, so as velocity is equal to E over B, so because these two phase forces are balanced, so what going to happen to your punya charge is going to move in straight line. Means that it won't be deflected either to up or down. So you're going to move in the straight line. So the only forces, the only charge yang move dalam straight line yang akan masuk dalam mass spectrometer. Okay, so what's going to happen in the spectrometer pula? So kata this is your charge, this is a positive charge. Okay, so as your velocity is to the right, masih ke kanan, in what direction is your punya force? Okay, so kita guna right hand palm rule. Kalau saya guna yang biasa je lah. Kalau guna yang tu tak boleh nak buat dalam video. So you akan masukkan you punya ibu jari will be directions of force. Okay, fingers V ke kanan, magnetic field ke dalam into the plate. So you can see that the force acting on the charge at this position will be FB ke atas ni lah. Okay, so dalam mass spectrometer ni, there's only presence of magnetic field, there's no electric field. Okay, so dia takkan ada electric force lah. The only thing force yang ada adalah electric field, magnetic force. So bila V tarik ke kanan, FB ke atas, you punya ni akan bergerak ke sini. Okay, so kalau at this position, katalah kita ada posisi kat situ, velocity ke atas, FB awak akan ke dalam. So in a way, gonna make a circular motion, then gonna hit the plate here. So kita akan measure you punya diameter ni lah, because it will be the center of the circle. Okay, center of circle kat sini akan jadi radius. So tempat yang hit ni akan jadi semicircle, patutnya macam tu. Right, so from that, what we can do adalah kita akan kata FB ni sama dengan FC. Okay, FB adalah QVB sin theta, FC adalah MV squared over radius. Okay, so theta will be 90 degree because theta is velocity dan magnetic field, which is 90 degree. Okay, so QVB, so kita nak, sekarang ni kita nak mass. So QVBR over V square. So kita cancelkan V. So QBR over V, dia will be the mass. Okay, so this equation, so tadi daripada mass spectrometer ni, we're going to find adalah radius ni. So radius equal to R equal to diameter per 2. So you gotta put in mind that dia punya mass, it might be different from the velocity selector tadi. Okay, so then we can determine the mass of the charge. So daripada mass of the charge nanti kita will compare dengan periodic table lah, to know which is that particle tu apa benda. Okay,